Okay, so let's talk about some geometric sequences in geometric series. So a blank is a list of numbers where each term is found by multiplying the previous term by a constant. So this is a geometric sequence. A lot of times we think about it as repeated multiplication. A geometric sequence and series are in the form of an exponential equation. So we're going to see this form a lot when we see a geometric sequence because this is the legitimate form that we're looking for. Something times something to the nth power. R is what we call the common ratio. So when we're looking at geometric infinite series, we look for the value of R to determine if we are converging or diverging. The reason why is because we have two types of exponentials. Our first type is one that looks like this, which happens when we have R that's greater than 1. The second type happens when R is between 0 and 1. We'll talk about negative numbers later. When it's between 0 and 1, we get something that looks like this. So this is when R is between 0 and 1. So if we look here, if I were to add all of these terms together, these terms are getting bigger and bigger. So when R is greater than 1, we're going to diverge. On the other hand, our terms over here are getting smaller and smaller and smaller. So our terms over here are going to converge. So we can go to even further to say our series converges that is not how you spell converges. I just skipped a couple letters in there. Converges when the absolute value of R is less than 1. So if we're between 0 and 1 or negative 1 and 1, realistically, we are going to converge. And we're going to diverge when the absolute value of R is greater than or equal to 1. And it's just based off of what our graph looks like. If we were to reflect these over the x-axis, this is going to give us when we have a negative in the front, negative in the front. When R is negative, we end up with these kind of weird graphs that go back and forward. When we have an R value bigger than 1, it looks like that. And when we have a value less than 1, it's going to be the same, but that value is getting closer to our thing instead. So it's kind of funneling in. So if we have a convergent geometric series, we can use the following equation to help us find where it converges to. So this only works for geometric series. So our sum is equal to our first term divided by 1 minus R. I like to write first term only because what our first term in our sequence or series is not necessarily always when we plug in 1, but sometimes it is. So we're going to look at some examples of what that looks like in just a second.